Assalamualaikum warahmatullahi wabarakatuh. In this video presentation, we will explain about geothermal power generation. Before that, I will introduce our group members. First one is Muhammad Shaifuddin bin Jaafar, B0522100036, and second one is me, Amirul Akimin Azalan, B0522100064, and the last one is Nasrin Adila binti Saharani, B0522100038.
The objective of this presentation is about study of geothermal power generation, review the basic construction of geothermal energy, study the working principle of geothermal energy, and lastly, can be specified example of power generation site. Now, we can go to the introduction of our presentation.
Geothermal energy is heat that is generated within the earth. Geo means earth and thermal means heat in Greek. It is renewable resource that can be harvested for human use. Geothermal energy is a type of renewable energy taken from the earth's core. It comes from heat generated during the original formation of the planet and the radioactive decay of the materials. This thermal energy is stored in rocks and fluids in the center of the earth. The difference between the temperature in the earth's core and the surface drives a continuous conduction of thermal energy from the center to the exterior of the planet. High temperatures of over 4,000 Celsius cause some of the rock in the center of the earth to melt and form hot molten rocks called magma. Thermal energy contained in the rocks and fluids can be found from shallow deeps right down to several miles below the Earth's surface. Here, the source of the heat is Earth, hence the name is geothermal. Heat inside the Earth is available at a depth of more than 18 kilometers. In some locations, it is available at a depth from 300 to 3,000 meters. Such locations are referred to as geothermal fields. Next, there are three types of geothermal: direct geothermal energy, geothermal heat pumps, and geothermal power plants. Direct geothermal energy can be accessed in areas where hot springs or geothermal reservoirs are near the surface of the earth. Geothermal heat pumps utilize a series of underground pipes, an electric compressor, and a heat exchanger to absorb and transfer heat. Geothermal heat pumps usually provide heating and cooling for single homes and can also be used for large-scale commercial projects as well too. Geothermal heat pumps harvest the energy by extending at most a few hundred feet below the Earth's surface. Geothermal power plants also harness the heat of the Earth through hot water and steam. In these plants, heat is used to generate electricity. Geothermal power plants are usually much bigger in size and output. It typically provides electricity for a city or region and can also be used for large-scale commercial projects as well. To accomplish this, geothermal power plants harvest the energy about 10 to 30,000 feet below the Earth's surface. In this slide, there are three pictures for each type of geothermal. In the 23rd century, demand for electricity led to the consideration of geothermal power as a generating source. Prince Piero Ginori Conti tested the first geothermal power generator on 4 July 1904 in Lardirello, Italy. It successfully lit 4 light bulbs.
So now we are on basic construction of geothermal power generation. To generate the energy in geothermal power plants, we use steam as a method. The steam originates from hot water reservoirs located several miles below the surface of the earth. Steam drives a turbine which in turns on a generator to produce power. Geothermal power plants come in three different varieties, that is dry steam, flash steam, and binary cycle steam. So now is the first type of geothermal power generation system, that is dry steam system. A dry steam power plant draws from underground resource of steam. The steam is piped directly from underground wells to the power plant where it is directed into a turbine or generator unit. There are only two known underground resources of steam in the United States. The first one is the geysers in Northern California. Second one, Yellowstone National Park in Wyoming, where there is a well-known geyser called Old Faithful. Since Yellowstone is protected from development, the only dry steam plants in the country are at the geysers. A dry steam system requires a rock catcher to remove large solids, a centrifugal separator to remove condensate and small solid particulates. Condensate drains along the pipeline, and a finer scrubber to remove small particulates and dissolved solids. The next type of geothermal power generation system is flash steam system. Flash steam power plants are the most common and used geothermal reservoirs of water with temperature greater than 360 Fahrenheit or 182 Celsius. This very hot water flows up through wells in the ground under its own pressure. As it flows upward, the pressure decreases and some of the hot water boils into steam. The steam is then separated from the water and used to power a turbine or generator. Any leftover water and condensed steam are injected back into the reservoir, making this a sustainable resource. Flash steam power plant process is take high pressure hot water from deep inside the earth and convert it to steam that drives generator turbines. When the steam cools, it condenses to water and is injected back into the ground to be used again. And the last type of geothermal power generation system is binary cycle system. Binary cycle power plants operate on water at lower temperatures of about 225 until 360 Fahrenheit or 107 until 182 Celsius. Binary cycle plants use the heat from the hot water to boil a working fluid, usually an organic compound with a low boiling point. The working fluid is vaporized in a heat exchanger and used to turn a turbine. The water is then injected back into the ground to be reheated. The water and the working fluid are kept separated during the whole process, so there are little or no air emissions. There are two types of geothermal resources can be used in binary cycle power plants to generate electricity. First one is enhanced geothermal system (EGS), and the second one is low temperatures or co-produced resource. This picture shows us how the binary cycle system works, from injection well and production well to the heat exchanger and through the turbine, and the last one is generator. In this slide, I will explain about enhanced geothermal system (EGS). Enhanced geothermal system provide geothermal power by tapping into the Earth's deep geothermal resources that are otherwise not economical due to lack of water, location, or rock type. The US Geological Survey estimates that potentially 500,000 megawatts of EGS resource is available in the western US, or about half of the current installed electric power generating capacity in the United States. In this slide, I will explain about low temperature and co-produced resource. Low temperature and co-produced geothermal resources are typically found at temperatures of 300 Fahrenheit or 150 Celsius or less. Some low temperature resources can be harnessed to generate electricity using binary cycle technology. Co-produced hot water is a byproduct of oil and gas wells in the United States. This hot water is being tested for its potential to produce electricity, helping to lower greenhouse gas emission and extend the life of oil and gas fields.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shaifuddin bin Jaafar, metric number B0522011136. My part is about the operation and the basic principle. Okay, here there are three basic type of the geothermal power plants. There is dry steam plants, flash steam plants, and binary cycle power plants. Okay, here I would like to talk first, dry steam power plant. Okay, there are actually 8 section or the 8 process. Firstly, it's about geothermal reservoir. Okay, the geothermal reservoir. Okay, the dry steam power plants are usually located in the high temperature geothermal reservoir, and it's usually underground of the hot water steam, and it is created by the earth's internal heat. Next is the well drilling. The wells are drilled into the geothermal reservoir to tap into the high temperature steam, and also wells have a similarity to gas oil or gas wells. Next is steam extraction. Here the process are where the steam are extract due in the wells by extract the steam in the underground of the geothermal reservoir and extract by the wells. Okay, next is the steam separation. Here the extract steam usually contains some of the water vapor and other impurities. Okay, here we must separate the steam and the water because the turbine are spin or beaten by only the steam. Here at the turbine operation, the dry steam is flow to the turbine with the high pressure and high temperature, which the turbine blades are spinning, causing of the dry steam. And here there are kinetic energy converted to the mechanical energy. Next, the generator because of the spinning turbine are connected to the generator. Because of the turbines of the turbine turns convert the mechanical into the electrical energy. Next, the power distribution. After we got the electrical energy, the power are distributed to the consumer. And lastly, where the steam are go after the process, they are the condense of the steam back into the water and re-injected to the geothermal reservoir, and they are sustain the pressure and maintain of the efficiency of the system. Next, we go to the flash steam power plants. Here there have a lot of the similarities due to the dry steam power plants, but here we have the little bit difference, which is the flash tank. Here, the high pressure hot water is then directed into the flash tank where the pressure is rapidly reduced. This sudden pressure drop causes a portion of the water to instantly flash into the steam due to the release of the latent heat. In the flash tank, the water they are extract, the hot water that extract to the flash tank, and here we release the steam. Okay, next, the steam go to the separator of the separator equipment where the flash steam is separated from the remaining liquid water. This separation can be achieved through the various mechanisms such as cyclone separator or other type of separation equipment. Then they are similar to the dry steam power plants, where they have a turbine operation, generator, power distribution, and also the condensation and reinjection. Okay, the next slide I will show you. This is a little bit how the flash steam power plant are convert into the diagram. And next is the binary cycle power plants. Okay, among the three, there have a lot of similarities, but I just focus in the difference process. Okay, here the difference is here at the heat exchange, where in the process the heat are exchanged to the secondary working fluid with the lower boiling point. Then the next process is the evaporation of the secondary fluid, where the heat causes the secondary secondary working fluids to vaporize or turn into the gas. Since the secondary fluid has a lower boiling point than water, it vaporizes at a lower temperature, making it suitable for the moderate temperature geothermal reservoir. Then the steam goes to the turbine operation, where the turbine are spinning and the convert into where the kinetic energy to the mechanical energy, go to the generator, converted to the electrical energy, and the electrical energy distributed to the consumer. And lastly, the steam are condensed into the liquid in the condenser and re-injected to the geothermal, and can the process cycle. And lastly, there are these figures of the diagram where how the binary cycle power plants are doing their job. Okay, that's all from me. Thank you.
Example of power generation sites. First, Malibong Geothermal Power Station, Philippines. With an output capacity of 232.5 megawatt, this power station in the Philippines is the 8th largest in the world. This plant is owned by the Energy Development Corporation and it supplies Luzon Island with energy. It has been operating since 1994 and has expected lifespan of at least 30 more years. It is actually the largest single-roof geothermal power plant in the world, and it is situated in an area that many people would call paradise. Second, the Geysers Geothermal Complex, USA. This large complex, located about 100 km north of San Francisco, California, is made up of 18 power plants offering an active production capacity of 900 megawatt. It's huge, spread across 45 square miles, and generates enough energy to power almost 1 million homes.